In today's class, we're going to do digital and analog signals, which is a part of electromagnetic spectrum. All right. So there are two types of signals. One is analog, one is digital. The thing about analog signals is that they vary continuously. What happens? They vary continuously. If you can, which means they can take any value. They can take any value. If you can see this diagram for analog signal, it's going from here. It's like a wave. It's like a wave. Yes. So obviously the calculations, the numbers in a wave will vary. You can take any values. Talking about a digital signal. A digital signal can take one of the two discrete values. One of the two discrete values. What do we mean by discrete values? Example, you can say you can either take 1 or you can take 0. You can take high or you can take low. You can take on or you can take off. This is an example of a digital signal. One, it's the example here is given by 1 and 0. So if it's 0, it will go like this. If it's 1, it's go like this. So this is an example of digital signals. I hope this is clear. Moving forward, the next topic is transmission of sound. The next topic is transmission of sound. Sound waves can be transmitted as a digital or analog signal. All right. Sound waves can be transmitted as a digital or analog signal. The signal which gets converted before the transmission and after being received. For example, if I'm telling you that this is the signal which is going, let's say the signal is a wave, okay, it's an analog signal. Before transmission, the signal will change. Ignore my handwriting. I hope you and just focus on the understanding of the concept. Don't look at my handwriting. So before transmission and after the signal is being converted, and after this is when the signal is being converted. So after being converted, and then at the other end it will get received. Yeah. So this side it's becoming received. So before transmission and after transmission. All right. So in both the cases, what will happen is that before the transmission, the signal is converted from analog to digital. A to D, analog to digital. Okay. After being received, the signal is converted from digital to analog. Completely opposite. I'll write it down here. After transmission, the signal is converted. These are very, very, very important points in the IGCSE past paper for physics. Is converted from before the transmission, it was converted from analog to digital. After the transmission, the signal is converted from digital to analog. And how it is converted? It has a converter called ADC, analog to digital converter. It is a machine, it is an equipment that converts this signals. What are the benefits? What do you think? Why is it used, and what do you think is the benefits of digital signaling? Benefits of digital signaling. I'm writing it in the short form. Signal. What are the benefits? So, an analog signal consists of varying frequency, like we discussed earlier, that any values can be taken in analog. It can consist of varying frequency or amplitude. So, examples of analog technology, they include telephone transmission, and some broadcasting as well. Okay, then a digital signal is generated and processed into two states, 1 or 0. This is an example. Here, analog versus digital. This is the analog signal, this is the digital signal, 1 or 0. Or you can also say it's high or it's low. Okay. What are the key advantages? Key advantages can be that the signal can be regenerated. What are the key advantages of data in digital form? I forgot to add one thing, in digital form. Okay, so the signal can be regenerated. Okay, to take down the notes, what you can do is take the screenshots, and for more lectures, for more videos, please subscribe to the channel and press the bell icon. Okay, signal can be regenerated. Why can they be regenerated? What's the advantage? So there is less voice, minimal voice. What do you call it? Minimal noise. All right, because of the accurate signal generation. Okay, in this one, because in digital form, mostly things are accurate means they are always right. So due to the accurate generation, the range of digital signal is larger. The range of digital signal is larger than the range of analog signal. So you're comparing it from digital to analog. Range of digital signal is larger than analog. Because why? It can cover large distance. Digital signals enable increased rate. I'll write this point down as well. It's very, 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 very important point. Digital signal enable an increased rate of transmission. Okay, compared to analog. Extra data can also be added. After all these data, extra data can also be added in the digital form, so that the signal can be checked for errors. But in digital form, obviously, when it's accurate, it's digital, it is using digital technology, I don't think so there will be any errors. So see you in the next lecture. Till then, goodbye.